All right, part 1 left off for the final review. Just finishing up number 20. Here's 21 at the bottom here. When I did this one, I initially did it with keeping in mind the Slope-Intercept Form, which is right here. Y equals mx plus b. Now, some people are thinking, well, that's not the chapter for this, but it is. If you have a word problem that talks about a rate, this is $1.20 per mile, that's a rate. A rate is a slope. A rate of change is a slope. So you can think about it as the slope-intercept form. Form of a linear equation, or you can think of it, in class I mentioned some other words for this. This is the end number, okay? In this case, that would be the cost of the taxi ride, or the total cost, okay? Sometimes it's the total number. Most of the time it's a cost. Sometimes it's, we did some with a population growth. It changes by this many per year, and after this many years, this is how many is left. So I think a better word for this end number would be total, okay? And then the rate or the slope, that's what this is right here, and that's plus or minus a rate, okay, is usually what I put in for that one. And this is multiplied, your m is multiplied by your x, and this would be, this, I call this the number of something, number of things. Number of miles. If you have a cost per item, it's the amount, that's the number of items that you have. Let's see, in the population growth one, it was number of years. So each year the rate went up or down by this many. And then it's always plus right here, and then I call this the start number. Okay, if you're talking about a bank account, how much did you put in the account? That's how much the account started with, and then it went down by so much per week or per day or per year, and you ended up with a total amount. Population, this is the population it started with. In this case, it's $20 per ride. Okay, so here's B. The 1.2 is the rate. The 17 is the number of miles. Okay, so you put all that together and you write down the total cost. The word problems on the final, you must write an equation out that makes sense, that actually adds up, or, you know, if you're going to pick up your calculator and do something in it, write down what you're putting in there. This is $1.20 times 17. Get that number, add 20, and that's going to be your total cost. Okay? So however you want to put it, however you want to think about it, that's the final answer. Excuse me. All right, now on to graphing. The most difficult part of this is substituting in this number. Remember, all ordered pairs are an X and then a Y. Always. Always, always. This is an X, this is a Y. That's always first. All right, so when it's in this form, they want to know what A is. In other words, they want you to put -2 in, -2 in for X. See how this is an X here? -2 in for X. Multiply a -1/2 times a -2 and subtract 1, and what do you get? That's going to be your A. So in this case, I like to multiply my fractions this way. I like to put, if it's a whole number that multiplied by a fraction, I put the whole number in the numerator part on the top, and then put it over 1. So I'm multiplying across the top. That's going to be a +2. And then this is a 2 times a 1, so that's a 2. So that is a 2 over 2 minus the 1 in the problem, okay? 2 over 2 is a 1. 1 minus 1 is 0. So that means A is 0. So that means my ordered pair is negative 2, 0. If you go down here, how do we graph? We always start at the origin. We don't put a dot there. I'm just trying to say that's where we start. So we pause over the origin, which is the center where the y and the x-axis meet each other. And then we always go to the x first. We always go to the x first. So in this case, x is at negative 2. And then we would be going up or down on the y-axis. Here, let me explain this way. Let's say there's a dot right here. How do you label this dot right here? Well, we always go over and find our x first. So if you keep your eye on these numbers, that's a 2. A 2 is going to go somewhere, and a 3 is going to go somewhere else. That's on the y-axis is the 3, so that's the y. On the x-axis, that's a 2. I think that's what makes the 0 ones a little difficult. So 0, the x is a negative 2, so we go over here, and then we stop there and go ahead and put a dot because the y is 0. This is a 0, okay? For an x or 0 for a y. That's where it meets. So there's a 0 somewhere and a negative 2 somewhere. So remember, the negative 2 is on the x-axis and the 0 is on the y-axis. Okay? So that's what A is 0. And then that's where it's plotted. The next one, you put a negative 1 in for x. Where is... Yeah, negative 1 in for x. So a negative 1 over 1. So negative 1 times negative 1 is a positive 1. 2 times 1 is a positive 2. So all this right here turns into this. Subtract 1, put it in your calculator. That gives you a half. That makes sense. If you have a negative whole 1, you take half of it away. You have a negative half left. Okay? That's for B. So that's a little hard to graph. That's for B. So you go back on the x-axis to the negative 1, and then you go down a half. Do your best to do that, okay? The next one, if you crunch this out, anything times 0 is 0, so it's just negative 1. So 0, negative 1. When x is 0, you're not going left or right, you're just going up or down to the y, so that's there, okay? And then 1 goes over to 1, and then down goes there, okay? And if it came from a linear equation, then it better make a line when you put them all on the graph, okay? Excuse me. And remember your slope formula? So I go ahead, if you're given 2 points, the only thing you can do is find the slope, okay? So I go ahead and label this as point number 1, and this is point number 2. So that's x1, and that's y1, and that's x2, and that's y2. And then this slope formula is the way you put that together, okay? So y2 is 8. The slope formula itself has a negative in it, so make sure you're putting these negatives in there because of these negatives in here, okay? And then if 8 is positive, that's just a positive 8. If any of these numbers are negative, you're going to add them to this. If this was a negative 1 instead of a 0, it would be a double negative. Subtract a negative 1, okay? But this goes like this, and then you add across the top and add across the bottom. And then make sure that this number right here is reduced, in reduced form. It can be an improper fraction like it is now. That's what we prefer, okay? So if this problem said, put your final answer in integer or fraction form, it always implies that you need a reduced fraction. So if this is 8 over 4, your answer would be 2, but it's 8 over 5. That cannot be reduced, and it can't be turned into a whole number. So you just leave it like that, okay? 24, put the following in slope-intercept form. This is not currently in slope-intercept form. What form is it in? It's in point-slope form. All right, it's in a different form. It just says put it in there. So all we're doing is treating it like any linear equation. We're going to distribute the 2, okay? And that leaves us here. And then we want it in slope-intercept form. What's slope-intercept form? So we need that y, we need the x, and then the m and the b are going to be the numbers, okay, the slope and the y-intercept. So we're going to move that 3, because I need y alone on one side. Move that over by adding its opposite. That's going to go away, so you get 2x, and then make sure you're adding the constant to the constant, so that's going to give you a 1. And that's it. That's all they want you to do for that one. The ones on the final are going to have quite a few steps. I don't know that you get one that simple, but you should certainly know how to convert from one form to the other. All right, find equation of the line with a slope of -1 and a y-intercept of -9. Put your numbers in this form. For some reason, people get a little... I don't think they know what to do with the negative. So either one of these is accepted. It has to be, the slope is -1, so the negative x term has to be there. And the b is a -9, and it has to be in this order, okay? All right, graph this equation. Sorry, the y is missing right there. So when you look, this is in slope-intercept form as you see it. All right, that means that's the m, that's the b as it sits there because it's in slope-intercept form already. Step 1 for graphing any equation is to look at the ordered pair that you can put on the graph. So b, this is a b, okay? B is -4. Any b's are 0b. So whatever's sitting there for b can be put next to a 0. And that's your first thing you're graphing. That's your x, that's your y. You come over here, and x is 0, which means you don't go to the left, you don't go to the right, you stay at the origin, and then because y is -4, go down to -4 and put a dot. Okay? Then you can use rise over run to find your next point. So the slope is at -1/2. So rise over run. Rise must be on top. So in this case, I'm going to go up 1, kind of pause, and then go back 2 to find the other dot. This is a negative slope. Do you remember our slopes? Positive goes this way, negative goes this way, 0 goes this way, do not exist goes that way. I try to think of it as mountain climbing. So you're positive and excited to go up to the top of the mountain. When you get up to the top, you have to go back home, so you're a little sad, and you come back down, so it's negative. And then walking back to the car, some people call that 0 fun. And then you accidentally drove your car off into a ditch, and you don't exist anymore. That's how they remember all the different slopes. And the directions they go. So this is a negative slope, right? There's a minus there. That's a negative. Don't forget that double negatives equal positives, okay? Positives go this way. This is a negative slope, so it has to go that way. So if you get confused about that, make sure you find your B, then notice if your slope is positive or negative, and make sure your final line goes in the right direction. This is a negative slope, so it makes sense that that works there. Also, if you say that -2 -3 works as a solution to this equation, the -3 would be the y, the -2 would be the x. You can always put them back in. That's going to be +2 over 2, which is a 2. No, +2 over 2, which is a 1, -4 equals -3. Yeah, checking, you can still mess it up. But that's correct, okay? This one, this equation, excuse me, is not in slope-intercept form. So I can't just look at it and know my B. I have to turn it around, which means I have to put it in slope-intercept form. That means move this way. And these are not like terms, so do not put them together. Put them side by side. Remember, that's going to be heading towards your B, and that you're going to be heading towards your slope. And then the y has to be alone. So it takes everything divided by 3. That's what this equation is in slope-intercept form. So that's my B. So that's 0, 2. Go up to 0, 2. Remember, this is the y-axis, so your B is always, always, always on the y-axis. Okay. And then to find the other one, you go up 2 and over 3 to find another point. Okay. And then for these two, excuse me, this is odd looking because there's no x. And usually when you see a y equals, you have an mx plus b. Well, this turns out to be your b because your m is 0. Okay, so that means that is the b. That means this is the first point. You go ahead and put that there. And because it's a 0 slope, it has to go straight across. It has no tilt. It has 0 tilt. Okay. So you can find any other point on the line to hold it straight. Any of these will work. Just pick one. Okay. 2 points make a line, minimum. And then this last one here, this line goes this way. It's not 0, so it must be this way, which is does not exist. Okay. So if the slope doesn't exist, and there is no y-intercept, right? That's why there is no y-intercept. Then you can't put it in slope-intercept form. So those are the ones that start with an x equal. So x equals wherever it goes through the x-axis. So this is the x-axis, and this goes through at -9. Watch the grid if it doesn't go by 2's. This one's weird. It goes by 5 on the y-axis and 2 by the x, just to make it difficult. So make sure you're putting an x equals. Y equals 9 doesn't look anything like that. Y equals 9 would look like probably right through there, right? That's y equals 9. All right, so be careful with those. All right, gonna have to, let's see if I can do, it's gonna take a while. All right, let's do this a little faster. Okay, so here's my slope. It says goes through 2 points. The only thing you do for 2 points is find your slope. Watch the double negatives here. Go across the top, you get a positive 24, and across the bottom. Don't forget that this negative is in this formula. So if you have negatives in your points also, you should be seeing 2 negatives, and then handle them correctly in your calculator. And you'll end up with a slope of -6. Do that again for this one. You end up with a slope of -6. When slopes are the same, they are parallel, right? If both of those lines went on the same graph, they would never cross each other. So therefore, they're parallel. If it was perpendicular, it would be opposite sign and reciprocal. Okay. Neither is when neither of these apply. Okay. Write an equation of the line perpendicular to this line that passes through this point. So they gave you this equation here to let you know that that is the slope that you need to be perpendicular to. Okay. So if you have a negative slope that goes in that direction, and this m is a -4, you need another line that's perpendicular to it. The slope of this line is going to be a positive, an opposite sign, and flipped. It's going to be positive 1/4. Okay, is going to be the slope of the new equation that you're finding. Okay, so you need the point slope formula, which is this here. Put your m in that you want, the 1/4, and then put the ordered pair. We need to go back and use the ordered pair they gave us. So put the y in the y1 spot, the x in the x1, watch the double negative, put that together, and then distribute, and then reduce the fraction on the end, okay? And then do that all again. Let's see, yeah, so this slope is a -1/3. If we want something to be perpendicular, we need a slope of 3. So we're going to put that in with this point into our point slope, and that's what we get for that one. All right, I'm going to start a video for the last bit here.